when they have some of it filled in. In other words, in fact, let's look at 35. Let's start off by doing 35. It makes it a little easier to grasp the concept, and then we'll go back and do 34.
Okay.
Okay. So here, let me get my writing tablet right. Okay, so we have this as the given, and we're trying to prove that line C is parallel to line D.
Yeah.
And we don't know that. The only thing we know is line A is parallel to line B.
Okay.
Okay, so A is parallel to B, angle 2 is congruent to angle 3. What's the reason for that?
Given.
Okay. The measurement of angle 2 is equal to the measurement of angle 3.
Is that like alternate interior or something?
No, that's just the definition of congruency.
Oh, okay.
In other words, if I have angle A congruent to angle B, I can say that angle A equals angle B.
Okay.
It's a little bit of what appears to be an unnecessary step.
Okay.
And that's why everybody hates proofs. It's because of this part right here, where you have to prove that something is equal to itself or that kind of stuff. Okay? That's just the definition of congruency.
Okay.
Hold on one moment. My screen may go black for a second. Okay. And number 3, angle 2 and angle 4 are supplementary. Why are they supplementary?
Probably, I don't know, is it definition of supplementary?
It's the parallel lines theorem.
Let's talk. Wait, I've never heard of that before.
Yeah, I had to look it up in the book myself to know what the theorem was called. But let's talk about parallel lines, because there's nothing more important in geometry than parallel lines, and you'll get tested on it multiple times. Okay? In fact, when you go to take your ACT or SAT test in a couple of years, this is one of the most important principles. Okay. When you traverse 2 parallel lines, you create 8 angles. That one, 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 that one. What you really do is you only create 2 angles, A and B, and every other of those 6 angles is either A or B. If I want to know what that one is, it's a small one. Well, my small angle is B. In other words, one of these is going to be acute, and one of them is going to be obtuse. Okay? So, I know that is A, and that is B, and that is A, and that is A, and that is B. The other thing I know is that A and B are supplementary. That's the only thing you really need to know about parallel lines and transversals, is that you really only create 2 angles and that they are supplementary. Okay. Okay? If I tell you this angle is 25 degrees, then you know this angle is 25 degrees. Yeah. So, they say that angle 2, and vice versa. Let's talk about the corollary to this. If I tell you that that's 25 degrees and I tell you that that's 25 degrees, then these 2 lines are parallel. Okay. Works both ways. If they are parallel, these angles are equal, and if these angles are equal, those 2 lines are parallel. So if I'm trying to prove that these 2 lines are parallels, all I have to do is prove this angle is equal to that angle, or even that these 2 angles are supplementary. In other words, if I tell you that this one's 25 and this one's 155, they add to 180, that makes those 2 lines parallel. Okay. Okay? And that's critical for our proof here. Because if angle 2 and angle 4 are supplementary, then hold on a moment, I got lost in my logic. If angle 2 and angle 4 are supplementary, the reason they, I'm sorry, I was thinking
No,
we were
you're
going to
fine.
try to prove from that. They are supplementary because A is parallel to B. In other words, if I draw just A and just B, and then draw a line D, and I tell you that that angle is supplementary to that angle, that tells me that I know that they're parallel. Or if you tell me they are parallel, then I know those two angles are supplementary. So again, the reason for 3 is the parallel theorem.
Okay.
Okay. In fact, that's the first reason that's the parallel theorem. I think I lost a step here. Okay, let's look at 4. It says the reason is definition of supplementary angles. Well, what should go here in the statement?
I don't know, something about...
What is the definition of supplementary angles mean?
Did I add to 180?
That's what goes there. Angle 2 plus angle 4 equals 180. In other words, angle 2 plus angle 4 equals 180. And the reason is that's the definition of supplementary angles. And we've just said that they are supplementary. Okay? Now, the substitution property is what I want to use for statement 5. Well, what do you suppose they mean? In other words, I'm trying to prove that 3 and 4 are supplementary. So what would statement 5 most likely say?
I don't know. That's hard.
It is hard. It's a little difficult to do these, but once you do a few of them, you get used to it. It means this, what I'm writing.
Okay.
If angle 2 and angle 4 are equal to 180 degrees, and that's what statement 4 says, then we know that angle 2, the measurement is equal to angle 3. So by the substitution property, I can say angle 3 plus angle 4 is equal to 180. Because angle 3 is the same as angle 2.
Okay.
Okay? And again, definition of supplementary.
Yeah.
In other words, this line 5 says angle 3 plus angle 4 equals 180. Well, that means they're supplementary because of the definition of supplementary angles.
Okay.
And now the final statement is, therefore, C is parallel to D, because notice if I draw just angle 3 and angle 4, here's C, here's D. I'm going to draw a line B. There's angle 3, there's angle 4. If you tell me that 3 is supplementary to 4, I know those two lines are parallel.
Okay.
I know that C and D are parallel if angle 3 is supplementary to angle 4. So therefore, C is parallel to D based on the what?
I don't know.
The parallel theorem.
I've never heard of that. We didn't go over that.
Here, let me open it in my book and see exactly what it says. Well, you know, it's not really important that you, oops, helpful. You know, it's not necessary to memorize these theorems. What is necessary is to know their properties.
Okay.
Okay? In other words, you don't need to know the parallel theorem, even though it looks like you maybe do for this proof. But in reality, you could probably get away with saying parallel lines have corresponding angles that are supplementary. That's all you would need to say. Okay, hold on a minute though. What am I looking for here? Proving lines are parallel. I actually have a postulate 16 that is the corresponding angles converse, which says if corresponding angles are equal, then the lines are parallel. And corresponding angles in this case would be 5 and 3. Okay. And I have a few other theorems about transversals. And then I have a theorem about parallel and perpendicular. Parallel means they have the same slope. Oh no, that's different. That says if two lines are parallel to the same line, then they are parallel to each other. Yeah, probably the theorem that I kept saying was the parallel theorem is more the... No, here I'm looking at on page 143. It's called the Theorems about Parallel Lines. Theorem 3.4 is the alternate interior angles. 3.5 is the consecutive interior angles. 3.3 alternate exterior angles. 3.7 is perpendicular transversal. Now,
I think we did those.
Yeah, you probably did do those, and that's all fine and good. It tends to make it much more complicated than it needs to be, in my opinion. In other words, learning all of those corresponding angles and, you know, my original picture here, it's true that this angle, if I label these angles here, 1, 2, 3, 4, 5, 6, 7, 8, they do want you to know that angle 3 and angle 6 are alternate interior angles. That's their classification.
Okay.
The most important thing to know is that they're equal.
Okay.
If those two lines are parallel. Also, they would say that angle 1 and angle 5 are corresponding angles.
Okay.
They are equal.
So would angle 3 and angle 5, would those be like supplementary?
Yes.
Okay.
If they are supplementary, then those two lines are parallel.
Okay.
Because angle 3 is angle 2, and angle 5 is angle 1. So we know that 1 and 2 are always supplementary. So if 3 and 5 are supplementary, it means this line's parallel to that line. So you can learn all of those separate theorems. There's like 4 of them. But why? In other words, I don't know why they do that, because the simplest way to handle it is just to know that 1 is equal to 4, 5, and 8, and 2 is equal to 3, 6, and 7. In other words, any angle that's created that's the acute angle is 2. The obtuse angle is 1. And that's all you need to really remember.
Okay.
I think. I mean, to pass your geometry test, you might have to know these names, alternate exterior and alternate interior and all of that. But in terms of the meaning of it for geometry, you just really need to know what it means. Okay, so as far as the reason for number 7 here, C is parallel to D, I would just say if the, these are called, see, I don't even know their names, corresponding, no, not corresponding, consecutive. If the consecutive angles, in other words, we knew that 3 was supplementary to 4, those are consecutive angles. So the official reason why C is parallel to D is that consecutive angles are supplementary. That's the reason. Okay. That makes those two lines parallel. Or maybe you want to give the exact consecutive interior angle theorem. You could say that it's based on the consecutive interior angle theorem. Okay. I'm not even sure your theorem numbers are the same in your book as they are in mine. I don't think they are. I think everybody kind of makes up their own numbers. In other words, there's no math database where Theorem 3.5 is the consecutive interior angle theorem.
Yeah.
I don't think so. I might be wrong on that, but I don't believe so.
Well, we have like a worksheet for those, and they're different. Like postulate 3.5 is about like lines and points.
Yeah,
so I think
exactly.
they're all different.
Yeah, I think they're all different too. And again, it's not the number on the theorem that's important to remember. It's the property.
Yeah. Yeah.
All right, we're not going to have time. Let's see, we got about 10 minutes because I was 5 minutes late. So
Okay.
we can get started on 34.
Okay.
All right, so what's statement 1?
Just like the given
Yeah,
angle one.
all of the
Yeah.
givens.
Yeah.
Angle 1 is congruent to angle 2, and angle 3
Yeah.
is congruent to angle 4. So I would put that right there, and the reason is given.
Okay.
Okay, and our goal is to prove that AB is parallel to CD. Well,
Okay.
looking at it from the back forward, what do I need to prove? In other words, if I start out and I said to you, I want to prove AB is parallel to CD, what do I have to prove about these angles?
Well, angle 2 and angle 3 are like vertical angles.
Well, that's
right?
true, but that doesn't prove that AB is parallel to CD. What would? Got angle 1 and angle 4.
Oh, I didn't see that was there.
A lot of times this parallel line stuff is tricky because there's more than just transversals. In other words, in this case, they got 2 transversals. But that still means that angle 1, if angle 1 is equal to angle 4, then this line is parallel to this line.
Okay.
Okay, because they would be alternate interior angles. So because of the alternate interior angle theorem, that would make those lines parallel.
Okay.
So that's going to be our goal, is to prove that angle 1 is equal to angle 4. That'll be step 3. That'll be statement 3. Okay? All right. So statement 1 was the given. Statement 2, considering this proof on 35, then we have to make this similar analogy. In other words, they had to actually write a separate statement that said the measurement of angle 2 is equal to the measurement of angle 3.
Okay.
So that probably should be my number 2.
Okay.
And that would be the measurement of 1 is equal to the measurement of 2, and the measurement of 3 is equal to the measurement of 4.
Okay.
Okay, and then the reason for that is definition of congruency.
Okay.
Statement 3.
Let
Let me think for a second. Remember, we're trying to relate 1 and 4. So if I know the measurement of 1 is equal to the measurement of 2, and the measurement of 3 is equal to the measurement of 4, then what can statement 3 say?
Would it be like measurement of angle 1 is equal to the measurement of angle 4 because of the alternate interior angle?
Because of substitution property.
Oh.
In other words, at this point, we don't have any of those other things. In other words, we don't know yet. But statement 3 would simply be the measurement of angle 1 equals the measurement of angle 4 because we can substitute. In other words, we've just said that the measurement of angle 1 equals the measurement of angle 2, and the measurement of angle 3 equals the measurement of angle 4. Therefore, by the substitution property, I can substitute 1 for 2, and I can substitute 4 for 3.
Okay.
So I can get this only because of the substitution property.
Okay.
Statement 4. Angle 1 is congruent to angle 4.
Okay.
Definition of congruency.
Okay.
I don't think they left enough room because we need a fifth line that says
Yeah.
AB, line
Yeah.
AB is parallel to line CD because of the alternate interior parallel line congruency.
Okay.
Alternate interior angle theorem. That's what it is, the alternate interior angle theorem. And
Okay.
I'm not sure why they didn't include a 5 because I don't know of a single step here that we could have omitted.
Yeah.
I would have maybe omitted that step where we had to say that the measurement was equal to one another. Then,
Yeah.
I mean, that seems unnecessary, but they felt it was necessary in 35, so I figured we better do it in 34 also.
Okay.
And that's probably the safe thing to do if you come across a proof on a test and you have to do it. It's better to put in more statements than less.
Okay.
In other words, if we omitted this number 2 here, it might look fine. I mean, it sure looks like it would be fine. We should be able to go from angle 2 is congruent to angle 3 to saying angle 2 and angle 4 are supplementary. But we had to put that extra little step in there. So if ever you have a decision, go ahead and put that in. It won't cost you anything, I'm quite sure.
Okay.
As long as you put the right reason for it.
Okay.
Okay. That's probably a pretty good primer on proofs, actually. The biggest difficulty I have with proofs is when you get to a line that you have to say line AB is equal to line AB. Okay?
Oh, yeah.
That's because of the reflexive property of numbers. And you would have to say that. You would have to know that that's because of the reflexive property.
Yeah.
It's at this point that everybody starts shaking their head and saying, I hate proofs.
Yeah.
But if it proceeds orderly, I like the way they do it here, because you can kind of look ahead and figure out, well, what must the statement be here, because I'm seeing what statement 6 is, so I ought to be able to figure out what statement 5 is.
Okay. Yeah.
All right, that's probably a good place to stop.
Okay.
Let me ask you, man, what is going on? This started happening at the very end of your brother session. That's why I had to reboot. That's why I had to reboot. And it's happening now, but it didn't happen until halfway in. Yeah, my cursor starts jumping all around. I can't figure out what's going on. So I may lose you any second here. But
Okay.
how did your parents want to handle the bill? Do they want to pay by PayPal? Is one of them there by chance?
No, both of them are gone right now, actually.
Okay. Should I just send an invoice to either you or your brother's email? Will it get to your parents if I do that? Or you want to
Do you
give
have
me
my
their
mom's
email?
email?
Do you know
Yeah.
their email? Why don't you give me their email if you know it? Who's the invoice to?
Okay. F
As in
_ yeah.
Okay.
Squire, SQUIRE,
Okay.
at msn.com.
Okay. Is that your mom or dad?
It's like our family one, so
Okay.
yeah.
That's where I will send the invoice, and then they can
Okay.
choose to pay however they like. They can either pay by PayPal or send me a check, whatever.
Okay.
Okay? All right. I will talk to you next time. You'll be back in school next time, so you probably will have some review material. If you get a chance, take a picture of it like this and send it to my email address before the session. That way we can get right to it. If we're going to only have half-hour sessions, we need to make them as efficient as possible.
Okay.
All right. I will talk to you next time, Ari.
Okay, thank you.
You're welcome. Bye-bye.